Okay, hi students. I want to work through the review problems that I gave you last week. I've already worked through these and they're also attached to the email that you got. And so hopefully you've had a chance to work through these, and I'm going to talk through and kind of show you the things that I did in the review so to help you get ready for the test. So for the first problem, I'm just going to talk through this one. This was the one about a study about about dogs and their hip health, and they had 300 dogs that they were exposing to two different kinds of treatments, right? They had 300 dogs to choose from. They put 150 in each group, and then they evaluated them after 6 months. First question is, what would be an advantage of adding a control group to the design of this study? So remember, a control group is just a group that doesn't get any kind of a treatment, and it gives us a baseline to kind of compare. And so the advantage of having a control group in this study would be to determine whether or not any treatment was going to be effective at all. Okay, we'd be able to see if there was an improvement in these dogs that got any kind of a treatment, and we would compare them to ones that didn't get any kind of a treatment. Okay, and then for the second part, this has to do with the blocking, and the way that we talked about blocking in class had to do with a diet pill study, and we said that it might be beneficial to block that study by gender because we thought that probably males and females would react to a diet pill probably differently. All right, so here we're going to decide, are we going to block this by the breed of the dog, or would it be better to block by the different clinics? All right, so if you think about, we're talking about hip health, and I'm thinking that larger dogs probably have different kind of health issues in terms of their hips and their joints than small dogs do. So I think it might be more beneficial for us to block this by the breed of dog, in which we would take a breed of dog, let's say Labrador Retrievers, and we would expose half of those dogs to the glucosamine and half the dogs to the chondroitin, and we would compare the results of those two. Whereas if we block by the clinics, I'm thinking that these clinics probably have a kind of a range of different kinds of dogs there, and if you compared one clinic to another, I think that the distribution of the kinds of dogs at those two clinics is probably very similar, and you wouldn't gain anything by doing any blocking on the clinics. Okay, so there's a lot of stuff that I didn't write down on this one, but those are the things that should have come to mind when you're working through that first problem. Okay, and then question number 2 had to do with a class reunion. And at this class reunion, they asked the 50 people that were there about their incomes, and lo and behold, they had a $189,000 average income for the graduating class of 1988. Okay, and so a couple questions about this then. Would you expect the distribution of salaries to be skewed left, skewed right, or symmetric? All right, so if you think about salaries, there's probably a few people that have very high salaries here, and probably a lot of people that have kind of moderate salaries. And so my guess is that probably the distribution of salaries is probably skewed to the right. Okay, and there's probably some people in this group that make tons and tons of money. Right, but there's probably a lot of people that just make moderate incomes. All right, so part B, what would be a statistical advantage of using the median of the reported incomes rather than the mean? All right, so if you think about it, if this distribution is skewed to the right, what's going to happen is this mean is going to be kind of inflated. All right, that if you have somebody in here, let's say like Bill Gates, who makes billions of dollars a year, he's going to make that mean a lot higher than it normally would be. All right, when we think about measuring the center of a distribution, we typically want the center to be representative of a typical kind of a salary. All right, and so the median is just going to be if you put all those numbers in increasing order and pick the middle one. I think that the median is probably going to be more representative of a typical kind of a salary. Okay, now if you think about this problem, the last part of this one says, the director felt that the members who attended the reception may be different from the class as a whole. A more detailed survey of the class was planned to find better estimate for the income, as well as other facts about the alumni. The staff developed 2 methods based upon the available funds to carry out the survey. All right, now, so another issue that is probably going to be uh, mixed in here is these are the people that came to the reunion, all right? And if you think there's 50 people that attended this reunion, and if you have ever gone to one of your class reunions, or if you're going to go to a class reunion, the people that show up there are usually the people that are successful, the ones that were kind of popular in high school and so forth. And so I don't think that these 50 people are necessarily going to be representative of the entire class of 1988. All right, so we're going to end up with some bias here in this number as well. All right, and so the director felt that the members may be different, so he wants to carry out a little bit further study. There were 6,800 people in this graduating class, and so method one was send out an email to the 6,800 members of the class asking them to complete an online form. The staff estimates that they're going to get at least 600 of those back. Method two would be to select a simple random sample of the members of the class and contact the selected members directly by phone. Follow up to ensure that the responses are obtained. Because method two will require more time than method one, the staff estimates that they can only get 100 members of the class using this method. All right, so we've got a couple things that are good and a couple things that are bad here. Okay, number one, it'd be much better to have 600 people in our sample than 100. However, if you think about the problem in the initial survey was these are the 50 people that attended the class reunion. If you ask somebody about their salary and it's a voluntary response, I'll bet that the people that are going to respond to this are the ones that are kind of proud about their salaries and probably have higher salaries than normal. So because of that, if we can get this 100, even though it's a smaller number, that's not going to have much bias involved because it said they're going to take a random sample and they're going to follow up and make sure that they get the responses from everybody. Okay, so method two is a much better method in terms of estimating the a typical income. Okay, so a lot of talking on that one, but those are the things that you need to kind of keep in mind when you're writing up your answer to that one. Okay, so the rest of the problems I've worked through, and I think that if you look through these on your attached file, you can kind of follow along and see what I did. All right, but let me just work through a couple of these problems and show you how I got them set up. So first question, find the probability the student is a senior. Well, this is a fairly straightforward problem. There was 125 seniors out of 575 students, and so that gives you about 21.7%. Okay, find the probability the student is a freshman or a sophomore. All right, so there were 150 freshmen, 160 sophomores. That's a total of 310 underclassmen. And if you take 310 divided by 575, you're going to get about 54%. Okay, find the probability that a student participates in less than 2 activities. All right, well, less than 2 activities means 1 or none. And so there was 185 people that were involved in no activities and 170 in 1. That's 355 out of 575 is about 61.7%. Okay, find the probability a student is a sophomore and participates in 1 activity. All right, so for that one, there are 50 sophomores that are in exactly 1 activity out of 575. Again, is going to give you about 8.7%. Okay, so I think that those first 4 problems, those are fairly easy problems. I would expect most people to get those right. Okay, and then the rest of these problems involve a little bit more. So find the probability the student is a sophomore, all right, and we have to kind of remember what to do with this word or participates in 1 activity. All right, so the way that I did this one is I said, this is the probability that a student is a sophomore. This is the probability that a student is involved in 1 activity. All right, and then this number is the overlap. There are 50 students that were in both, and we have to subtract that out because those 50 kids got counted twice, and you're going to get 280 out of 575 is about 48.7. All right, now another way that you could do this is you could say, what is the probability that a student is in one of these 2 groups? Okay, so you could add up 45 and 50 and 40 and 35 and 40 and 70, and if you add up all those numbers, you're going to end up getting 280 out of 575 also. Okay, so 2 different approaches to the same problem. Okay, that are both correct. Okay, find the probability a student participates in one activity given that the student is a freshman. All right, so we're only concerned about the freshmen, and there's 150 of them, and of those 150, 45 of them were involved in one activity. 45 out of 150 is 30%. Okay, G, you just have to understand what the word disjoint means. Disjoint means that they don't have any overlap. Okay, so are the events the student's a freshman and the student participates in one activity disjoint? And the answer is no. There were 45, okay, 45 doesn't make any difference. There were some students that were in both groups. All right, now the last one, are the events the student is a freshman and the student participates in one activity independent? All right, so when we talked about this in class, we said independent means knowing something about one event doesn't change the probability of the other event. So I'm looking at what's the probability a student is involved in one activity given that they are freshmen. Okay, that was the question F, which was 45 out of 150 or 30%. All right, now I didn't mean for these to come out as close as they did, but the probability that a student is involved in one activity is 170 out of 575, which is 29.6%. All right, now going directly by what we said in class, if these two probabilities or these two proportions are not the same, then the answer is they are not independent. All right, now you could argue that if you rounded this to 30%, they would be independent, and I'll tell you that probably on the final exam, I'm not going to make these things come out as close as they did. Okay, you could probably argue either way, but to go with what we said in class, these are not equal, so they are not independent. All right. The next one I think was a question that was on maybe your second exam, was about the number of airline tickets sold for a flight that only has 38 seats. All right, and they're going to sell 41 tickets for this flight, and then we've got a probability distribution of the number of people who actually show up. So there are 38 passenger seats on the flight. What's the probability that everyone that shows up will get a seat? All right, well, everybody's going to get a seat if there is 38 or fewer passengers. So all I did here is I added up the probability of 36 and 37 and 38 and came up with 92%. All right, so 92% of the time, everybody that shows up gets a seat. Okay, to find the expected value, this is the formula that we had in class was a summation of taking all of the x's and multiplying by their corresponding probabilities. So 36 times 46% plus 37 times 30% and so on. If you multiply all those together and add them up, you're going to end up with the expected number of people that show up for this flight is going to be 36.9 passengers. All right, I didn't ask you very many questions about this, but that doesn't necessarily mean that there won't be several more questions on the exam about the binomial distribution. Okay, the binomial distribution, remember, we're counting the number of successes out of a number of trials. So a fair die is rolled 8 times, let x be the number of 6s rolled. So we need to identify a couple things here, that we've got 8 trials, and the probability of a success with a fair die is going to be 1 out of 6 is going to land on 6. All right, and you could write this as 16% or 16.7%, whichever you want. Okay, I'm not going to take off for rounding off those. All right, so the way that we did this on the calculator was we said we need to know what n is, and we need to know what p is, and we need to know how many successes there are. All right, so the binomial PDF command on your calculator is under second vars, and then you have to arrow down and make sure that you are using the PDF, because this is the probability of exactly 2 6s. All right, and when you put that in, you're going to end up with the answer being about 26%. All right, this other one is got two things going on. First of all, it's a range of numbers, and it's also a greater than. All right, so find the probability that more than 3 6s were rolled. So the calculator is going to give you the probability that you're going to get between 0 and a fixed number. So we want to know more than 3 means 4 or more. So this is 1 minus, and this would be the probability that x is less than or equal to 3 is going to give us 4 or more. All right, and then again on this one, make sure you're using the CDF because this is a range of values and not just one particular value. All right, so putting this in the calculator, you're going to get 1 minus about 96.9% is going to give you a little bit more than 3% for that answer. Okay, would it be unusual to roll more than 3 sixes? Well, I think that most people would look at this and say, well, if you look at the question that was just asked, what's the probability of rolling 3 or more? And the probability was only about 3%. You could use that as justification and say, yeah, it's unusual because the answer up here was only 3%, which is a very small probability. Or you could use our rule of thumb that we talked about in the book, was you could find the mean, okay, by taking, this is n times p, and you could find the standard deviation by taking n times p times q. You're going to get a mean of 133 and a standard deviation of 111. And our rule was to find the fence. So if you take the mean and add 2 standard deviations, you're going to get the fences at 3.55. Now the question says more than 3 sixes, which means 6 or more. And any number that's 4 or more is going to be more than 2 standard deviations above the mean. So this would be a perfectly good argument as well. Okay, and this is the one that the book uses, but we know how to calculate that probability, so we might as well use the probability as well. Okay, either one of those arguments would be fine on the exam. All right, we spent a lot of time working with the normal distribution, and so here are some typical kinds of questions about the normal distribution. A couple things to keep in mind. Drawing this picture I think is a good idea. All right, and then I would say that somewhere on your note sheet you probably want to make sure that you have something written down that tells you that this is the lower value, this is the upper value, this is the mean, and this is the standard deviation. All right, and if you put those in a wrong order, you're going to get the wrong answer. All right, so this one says, what's the probability that it will take more than 75 minutes to complete the exam? All right, so we got a normal distribution with a mean of 60 and a standard deviation of 12, and we want to know what's the probability that we're going to take more than 75 minutes. So putting that in the calculator with a normal CDF is going to give you about 10.5%. Okay, what proportion of students will take less than 51? All right, same kind of question, same distribution, but now we want to know what's the probability being to the left of 51. So lower bound would be negative infinity. The upper bound would be 51, the mean is 60, and standard deviation is 12, and you're going to end up with about 22.6%. All right, how long would you expect to wait for 90% of the students to get finished? All right, so this is, we want to find out what's the 90th percentile for finishing times. Okay, we can find the 90th percentile, but remember that this number that the calculator is going to give you is a z-score, and that's a number of standard deviations above or below the mean. So this is the mean plus this z-score times the standard deviation is going to put us at about 75.36. Okay, so we'd expect to wait about 75 and a half minutes before everybody, or that 90% were finished. Okay, then part D is, now we've got a sample of 16 students and we want to know what's the probability that their mean time is less than 55. All right, so this is where we have to make that adjustment in the standard deviation. Okay, it's sigma divided by the square root of n, so 12 divided by the square root of 16 is going to give you 3. So this is the same kind of question, except you're going to put 3 in for the standard deviation, and you're going to end up with about 4.7%. Okay, number 7 is using the binomial distribution and finding its mean and standard deviation. Okay, for the binomial distribution, this is a formula that you were given. Should probably be on your formula sheet that you're using on the exam. Okay, you're going to expect to get 14. The standard deviation, again, is a formula. Square root of NPQ is going to give you a standard deviation of about 3.175. Would you be surprised to get more than 16 red vehicles in a sample of 28? And the way that I would do this one is, I did this with calculating a z-score here, and we got negative 3.77. All right, so that means that 16 is more than 2 standard deviations below the mean, so my answer would be yes. All right, now you could also find the fence and say, how far is 16 below 28? So you could say, take 28 and subtract 2 standard deviations and find out where the lower fence is. I didn't do that on here, but let's see what that is. Okay, so 28 minus 2 times 3.175. And that's going to give me 21.65. All right, this is that lower fence, and 16 is well below 21.65, so the answer is still yes, with a little bit different explanation. Okay, either one of those explanations is perfectly fine. All right, I think you could also use a binomial CDF and find this probability, and I'll bet you're going to find that that probability is really low, which would also be a reasonable explanation. Okay, but don't forget to look for these things where I'm asking you to explain things, because you're not going to get a whole lot of points if you just say yes or no. Okay, make sure you explain your answers. All right, moving on to the next page. We had a question kind of like this on our, I think on this, maybe the first or second exam. So suppose that you've got license plates that are made up of 4 letters and 2 numbers, and you want to know how many different license plates you can make using this method. And this one, we're assuming that the numbers and the letters can be repeated. So if you got 4 letters in there, that's going to be 26 times itself 4 times. And then you've got 2 numbers. So that can be any of the 10 numbers. And if you multiply all that stuff together, you're going to end up with about 45.69 million. Okay, and then if the plates are made so that the letters and the numbers cannot be repeated, then you can get 26 different letters for the first one, but then we've already used one, so we only have 25 for the next one, 24 for the next, and 23 for the next. And then the same thing with the numbers. The first number could be any of 10, the second number could be any of 9, and if you multiply those out, you're going to get about 32 million. Okay, and then one of the last things we did was we talked about confidence intervals and hypothesis testing. All right, this should be very fresh in your mind from what we did just in the last week or so. Construct a 90% confidence interval for the proportion of eggs that are get broken during transport. So we've got to calculate first 64 out of 400 is what we got in our sample. That's 16%. So we're going to take that p hat plus or minus z star for 90% is 1.645. This is the standard deviation for that, and you're going to end up with your confidence interval being from about 13 to 19%. So the interpretation of this is I am 90% confident that between 13 and 19% of, and it's kind of important that you say of all eggs that get broken during transport. So it's not just about these 400 that we sampled, it's about all eggs that might be transported this way. All right, and then the hypothesis test, based upon this sample, is there sufficient evidence at the 5% level that to suggest that the proportion of broken eggs is greater than 10%? All right, so we're going to assume that it is 10%. The question kind of asks us to see if it's more than that. So this is the hypotheses. All right, make sure that you could define what P is here. P is the proportion of broken eggs during transport. We've got some conditions that need to be met. Both of these numbers end up being bigger than 5, and it did state in the problem that it was a simple random sample. So the conditions are all met. Then I want you to calculate a z-score. Okay, the z-score on this one comes out to be 4. And then to calculate the probability of getting a z-score greater than 4 is a really small probability. All right, so our decision is to reject the null hypothesis, and I want to know why you're rejecting it, and then I want to know what does that mean. So we have sufficient evidence to suggest that more than 10% of all eggs get broken during transport. Okay, so that's very similar to what we did just recently. And then on the very last, the last problem with inference. Okay, this one is about the mean. So I've got kind of the same structure here, but this is the x bar. This is still plus or minus a critical value, z star, and then this standard deviation is sigma divided by the square root of n. So I want to make sure that I'm keeping these things straight, that I'm using the correct standard deviation when I'm working with means, and I'm using the correct standard deviation when I'm working with proportions. All right, so when you clean this up, you're going to get that this runs from about 57 to almost 63. All right, now I did forget to do one thing on my answer key, and that was to interpret this, but the interpretation would be, I am 95% confident that the average number of points scored during the 1987 season is somewhere between 57 and almost 63 points per game. All right, then the next part of this is going to ask you to do a hypothesis test. And it says, does this sample provide sufficient evidence at the 5% level to suggest that the mean number of points scored in games in 1987 was greater than 57 points? All right, and you can probably look up here and say, you know what, 57 is just kind of barely inside this interval, but this interval isn't what I want you to do here. All right, if I'm asking you a question like this one, is there evidence at the 5% level, I want you to do a hypothesis test. All right, so our null hypothesis is we're going to assume that the average number of points in the 1987 season was the same as it was in 86. Okay, the question is asking us, has that mean increased, which means is the mean greater than 57? All right, now we still have this condition of simple random sample, and the problem did state that these were a simple random sample. I guess it didn't really state that. It says they just sampled 35 scores. All right, let's make an assumption there that this wasn't stated, but let's assume that it was a simple random sample. And the other condition is either the distribution is normal. Right? It didn't say anything in the problem that the distribution of points scored was normal, but our sample size is greater than 30. It was 35. Okay, so this wasn't stated, but I will tell you that on the final exam, it'll be clearly stated or not. Okay, so from there then, we ended up getting a sample that had a mean number of points with 60. We're going to calculate the z-score for that. We got 1.97. The p-value is the probability of getting a z-score greater than 1.97. So on the calculator, you should end up getting about 2.4%. Okay, now this one said at the 5% level, because this is smaller than 5%, we're going to reject the null hypothesis. Because our p-value is less than 0.05, we have sufficient evidence to suggest that the mean number of points scored in 1987 is greater than 57 points per game. All right, so I guess the conclusion here would be that the introduction of the three-point shot seems like it may have an effect on the total number of points that teams are scoring that next year. Okay, last page then. Okay, we also did some stuff with linear regression and correlation. Okay, and so here is, it says a company that services copy machines tracks the number of copies made per month against the number of users authorized to use the machine. All right, so I'm thinking that maybe like a university, there's a certain number of people that are authorized to use different copy machines, and then we want to keep track of the number of users versus the number of copies made. All right, and then keep in mind that this is in thousands over here on the vertical axis. Okay, so first, describe the strength, direction, and form of the relationship. All right, so strength of a relationship, I want to know, is it strong or weak? And if you look at the scatter plot, it looks like there's a pretty strong relationship between number of users and the number of copies made. Okay, because this kind of goes up to the right, as the number of users increases, the number of copies increases, there's a positive association. And then the idea of the form of this relationship is, generally we're going to call it either linear or not linear. Okay, anything that's not linear is going to have a definite curve to it. So you might see a scatter plot that looks like a parabola or maybe looks like an exponential function. All right, this one, it seems to me like a linear model is probably a decent model. All right, so strong and positive and linear. Okay, so which of the following do you think is closest to the correlation coefficient? All right, so because this is a pretty strong positive association, I'm going to throw out the negative choice. I'm going to also throw out the one that's close to 0. And then if you remember from class, we had that demonstration in class where I gave you some different scatter plots, and I told you the correlation coefficient. And we could barely see that there was a positive association when we were around anything less than about 0.5. So I think that probably because of all those reasons, this is a very strong positive association. I would say that something above 0.9 is probably reasonable. Okay, and then I've also given you the equation of the least squares regression line. Keep in mind that this y is the number of copies, and this x is the number of users. And so given interpretation of the slope is 414. All right, so the way that we should interpret the slope is it's a rate of change. All right, and so for each additional user, the number of copies increases by about 414 copies per month. Okay, so if you think about this in terms of the slope that you remember from algebra, this is a change in y divided by a change in x, and y is measured in copies, and x is measured in users. Right, and if you set that up that way, you end up getting copies per user, and I think that that kind of helps to make the interpretation. All right, and then also using this model to make a prediction. So suppose that you've got a department that has 21 users. How many copies would you expect them to make? Well, we're just going to plug 21 in for the number of users, and you should end up getting about 8,864. All right, and then also find the residual for this machine. All right, so if you were to graph this line, that line is going to look something like this. Okay, it's going to be a pretty good approximation of that relationship. Okay, it said the copier of 25 users made 8,820 copies. Find the residual for this machine. All right, so they're talking about these guys here, and what we want to be able to do is find the vertical distance between that point and the line. All right, so y in this case is the 8820. That's that point. And then we want to find the y coordinate of this point, which is kind of like we did in part B. Plug that into the formula, and you're going to get that if you got 25 users, the model predicts they're going to make about 10,500 copies. All right, and so if you take 8820 minus 10,520, you're going to end up with their residual being about negative 1,700. Okay, all right, and you should recognize that this number should be negative because that point is below the least squares regression line. Okay, so that's everything on the review. I will tell you that the final exam is not as long as the review, okay, and there's probably some things that are on the final that, well, some things that were on the review that are not necessarily going to be tested on the final, but things that you should probably have picked up along the way as well. I plan to be at the in that commons area probably around 2:30 or so on Tuesday. Remember that Tuesday is your final exam time. We're going to take it during class 3:30 until 5:30. Remember that you can bring in a sheet of notes, front and back. You can bring your calculator. All right, and some of you use the table that's in the book. If you want to bring the book and have it open to that table, that's fine too. Okay, so if you got any questions about anything here, make sure that you show up there before the exam at around 2:30, sometime between 2:30 and 3. And I want to get the exam started right away at 3 o'clock, or I'm sorry, at 3:30. But I will take a few questions at the beginning of that time if there are any. Okay, so hopefully this video has made a lot of sense to you. Hopefully you've kind of worked through this and everything is pretty, you remember how to do everything. You got to remember to probably go back and look at the linear regression stuff. Go back and read through the stuff about experimental design. Okay, we haven't seen that for a long, long time, so you may want to go back and review some of the vocabulary words there. Okay, so anyway, have a good weekend, and I will see you on Tuesday.